LeetCode problem number 191, number of 1 bits. So this problem gives us a unsigned integer, and the goal is to return the number of 1 bits it has in the integer, right? So for example, we have this long integer, so there's only 3 ones. So the approach would be to iterate through the numbers here, and then if it's a 1, we plus 1 into our count. Otherwise, we continue on, right? So my approach to that problem is exactly that, but I'll be using some voice operations. So let's talk about this 10% operator first. So this basically means if I have, let's say I have something like this, and okay, so if I were to apply the AND operator here, so what this AND operator means is, so what it means is if both of it, if both of it is 1, then I'll get a 1, right? So since both neither is 1, even if one of them is 0, right? For example here, this will become 0 as well, right? So 0, 0, and then this will be 1. Okay, so by comparing this with 1 itself, so we know that in binary 1 would be 0, 0, 0, 1. So this number is actually 1, 2, 3, 4, 5. This is 5, right? So we know 5, and if we AND this, so this will actually give us 1, right? Because after using the AND operator, we will get 1, right? Even if the rest are 1s as well, we will still get 1, because only this is 1. What this means is there is a 1 in our current number, the current bit that we're at, right? So if this was to be 4, for example, 4 will be like so. So this will give us 0, and the resulting will be 0, right? So again, if it's 5, there's a 1, then we get a 1. So that's why you see here, my count will plus equals to whether or not this number is a odd number, right? So if it's an odd number, meaning there's a 1 at the back. If it's even, there's no 1s, there's a 0, then this will be 0, so count will plus equals 0. Next we have this operator, this bit shift. So basically what bit shift is doing is, so let's say I have this bit, right? And if I were to shift 1, that means I'll be removing this number, right? So I'll bit shift one more time, removing this number, one more time, removing this number, right, like so. So there's also another one which shifts it to the left. So it does the same thing. I remove the bit on the left instead, right? So shift it one more time. Again, it doesn't have to be 1, it can be 2. Let's say I shift it to the right 2 times again. So it will be 1, 1, 2, and minus. Okay, so one thing you should note when shifting bits is, let's say I have this, this bit, right? If I were to shift it to the left by 1, so for doing that it would be 0, 0, 1, 0. So this from 1, it will become 2, right? I shift it again, so now this will become 4, right? So and I shift it again, then it become 8, right? 1, 2, 3. So you can also count it yourself, like I have been, because I'm not really that good in managing with bits, but pretty sure it's 4, pretty sure it's 8, right? Then it'll be 16 and 32 and so on. So basically this, what it's doing is times 2. to the bits we have. So same thing, if we were to, starting from 4, if we were to shift the bits to the right by 1, moving 1 zeros here, then this will turn into 2. Shift it again, turn into 1, and we shift it again, then it will be just 0. Okay, so that's basically what these two operations are. So let's go through the code. So I have a count here, starting with 0, and let's say the integer we have is 1011, right? So while n is more than 0, so right now n is the same as, I believe this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11, I think. By the way, the value of n doesn't really matter because we know 0 would mean that it's all zeros. So let's keep that aside. So n is 1011. So while n is more than 0, which it is, so count plus equals n with the an operation with 1. So in case this is a 1, right, remember if you were to do this, this will give us a 1, right? So count will plus 1. After that, we shift the bits to the right by 1, ampersand again, this will still give us 1, 2, shift it again, now this is 0, right? Because right now this n value is 2, doesn't really matter in this case, but it's a even number, so there's no 1 here. So we leave count as is and shift the bits, and we reach the last one, we get another one, shift it again, and now n is 0, right? There are no bits left in n, so n is effectively 0, and we return the count, which in this case is 3. You can see it matches the output given in the example. Okay, so this is a fairly simple question with a fairly simple and straightforward approach to this. Obviously, you can do this without using the bitwise operations, right? You can just do an modulus 2, right? And then here you just dy equals 2, right? Obviously, you can do this, it's the same thing, but at the end of the day, it is what it is. Okay, so that's all I have to show.